Hi, welcome to my video on circles, which has inscribed and central angles and arcs. And this is number 6 on inscribed and central angles and arcs. Number 6 video. I have a diagram drawn here, and I have the given information. It's O is the center of the circle. And this has to be a diameter. So I could have said that AP is a chord, which means that AP is the diameter. And we're given that the measure of the arc AV is 90 degrees. So the arc AV is 90 degrees. So that's 90 degrees from here to here. And as a result, we're also given, notice these two marks here. We're also given in the diagram that these AG is parallel to VP. And we have to know the properties of parallel lines. So let's see how we're going to be used. Property of parallel lines: alternate interior angles are equal, corresponding angles are equal, interior angles on the same side of transversal are supplementary. Many properties. So let's see which ones we're going to use. So we got this this arc is 90 degrees. So notice the angle APV is inscribed. Two chords with a common endpoint, and this angle APV is intercepting this arc. So that means that this angle right here is 45, because the inscribed angle that intercepts this arc is half the measure. Now we have the lines parallel, so that means we have a 45-degree angle here, because when lines are parallel, this is a transversal cutting through the lines, so these are alternate, so this angle and this angle are alternate interior. And let's continue. Now what else do we have? We're looking for X and Y. So in this triangle, let's see, we have this side is equal to this side. So OA and OG are equal because the radii of a circle. If these two sides are equal, then two angles are equal. So that means if this is X, then this one is also X, because the two of them are equal. So that means if this is 45, this X is 45. So we have X is 45 degrees. Now we got a 45 and a 45. That makes a 90, 180 degrees in a triangle. So 180 subtract 90 gives you a 90-degree angle right here. And as a result of a 90, because this is a 90-degree angle, Y is a 90-degree angle, because this is a diameter, which is 180 degrees. So if you got a 90 on one side, you got a 90 on another, because 90 plus 90 makes a straight angle 180. Or if we have this line is, because that's a 90, GO is perpendicular to AB, because it's perpendicular form 90-degree angles, so this is a 90. And so we got Y is a 90, and we want to get the measure of arc AG. The arc AG is 90 degrees, because the intercepted arc is the same size as the central angle. Again, properties around using the information we have, triangles, parallel lines, all come together. And the more math moves on, the more basic concepts you have to know. Now we have another one here. Prove chords of equal length intercept equal arcs on a circle. So we're given, let's do a no formal proof now. We're given chords of equal length. So let's draw two chords. Let's draw this chord and draw, let's say, this one. So let's call this chord AB and call this one TV. So chords of equal length. So that means this is a chord and this is a chord. So that means that AB is equal in length to TV. And on a circle, so we have a circle So let's name O right here. O is the center of the circle. Because the circle is a set of, these are the set of points on the circumference which are equal distance from the center. So what we have to do now to do this proof, we have to say, okay, what are we trying to prove? Chords of equal length intercept equal arcs. So these chords right here is cutting off the arc AB, and this chord VT is cutting off the arc TV. So we got to prove, because these chords segments are equal in length, we got to prove that the arcs have the same measure. The arcs have the same number of degrees. So to do this proof, let's draw some radii. So let's join B to O and A to O and OV and OT. Now what we have now is a pair of triangles. So if we can prove these triangles congruent, we can get what? To get these arcs equal, this arc here is equal to this central angle, and this arc here is equal to this central angle. So if I can get this angle right here, BOA and VOT equal to each other, then I can get the arcs equal. So here we go. We got the chords drawn. So let's do number one. Let's do statements and reasons. So let's do number one right here. Statement. We got the givens. So we got AB is equal to TV, and we got O as the center. Let's put that in number one. So this is what I call the givens. Now they're equal. So we have to, officially, I constructed, or I draw BO, AO, OV, and OT. That's called a construction. So I constructed those segments. Let's name that number 2. And number 3, we have they're equal. So let's go with B going with V, and let's go with A going with T. So we have, because the radii, we have OB equals OV, and we also have OA equal to OT. Remember, they're all equal, but what I'm doing, I'm saying that this chord goes with this, so I'm going to have B going with V and A going with T. So these are radii of circle are equal. Radii of a circle are equal. That means that we have this side is equal to this side given. These are equal. So I have a triangle, and I'm going to name it BOA is congruent to triangle VOT. And the reason for that is called SAS congruency. In other words, 3 sides of one triangle are equal to 3 sides of another, then the triangles are congruent. And as a result of that, I'm going to name this as angle 1, and this is angle 2. So I'm going to say angle 1 is equal to angle 2. It's sometimes easier to use numbers when you're doing proofs than use the naming with 3 letters, BOA and VOT. Angle 1 is equal to angle 2. Corresponding parts of congruent triangles are congruent. And again, this is all discussed in the chapter on proving congruent triangles, the unit on congruent triangles. And number 6, now we have angle 1 is equal to the measure of the arc AB. We have angle 2 is equal to, make that an arc, of VT. So that's the the measure of the central angle equals the measure of the arc. So the measure, let me write down measure here, measure of central angle equals the measure of the arc. So this is the central angle equals this arc. This is the central angle equals this arc. And as a result, we have 1 equals 2. There's 1 equals 2. That means that the arc AB is equal to the arc VT. And that's the transitive property. Angle 1 equals angle 2. There's 1 and 2. So we have transitive. That's the transitive. Transitive, I'm going to spell it right. Transitive property, PROP, of equality. Transitive property of equality. And that's the proof. So if two chords are equal, then the arcs that they cut off or intersect are equal. We'll use that in further proofs. Okay, let's do some exercises on that property. Again, each video I tried with each video to do one property at a time to explain them, because it gets very confusing when you put them all together. Number 1, I have a circle, and it says that I have this chord is equal to this chord. So I got two chords equal. So if the measure of the arc AB is 76, the measure of this arc is 76. That means the two chords are equal. That means the other arc is 76. Because if two chords are equal, they intercept equal arcs. Number 2, again, I have a circle, and I have O as the center. I have AD as a chord. So if AD is a chord, it means that it's the diameter also. Because a chord that goes through the middle of the circle, goes to the center, is the diameter. Now we have AB is equal to FH. So these two chords are equal. So if the arc AB is 80, so this arc AB is 80, that means that this arc right here is 80. So we have the arc FH is 80, because these two chords are equal, and equal chords intercept equal arcs. So this angle is 80. That means that this angle at O, the central angle, this angle is 80. So let's name this angle as 1. So angle 1 is equal to 80 degrees. Reason? Because the central angle and the intercepted arc have the same measure. And so we have this radius is equal to this radius, and these are all equal. These are all equal because of radii, but I'm only dealing with these two. So this radius equals this because the radii of a circle are equal. That means that this is the two sides of a triangle are equal, then the angles opposite those sides are equal. It's called the ITT. Two sides equal, two angles are equal. So that means this angle is equal to x. So we have 180 degrees in a triangle, and this is 180 plus 2x is equal to, oh, that's an 80. Sorry, 80. I said 180. 80 plus 2x is 180. That means 2x is 180 minus 80 is 100. And that means x is equal to 50 degrees. X is 50 degrees. In other words, this angle is 80. These two angles are equal. So 180 take away 80 is 100. And because they're equal, divide by 2 and I get 50. Okay, let's do another one. Again, more algebra coming now. I have a circle, and I have two chords of the circle marked equal. Because two chords are equal, then I know that these two angles are equal. And I also know because two chords are equal, these two arcs are equal. So we're told that the arc TK is this one, is 2x plus 80. and this chord, arc here, AC. Oh, what about K? Oh, that should be TN. I didn't adjust the naming of the angle. So this arc is TN, is 5x minus 10. Sorry about that. So this arc is equal to this arc. I just had a name wrong. I used a different diagram. And so again, so this K, this arc right here is equal to, let's name that. So this arc right here is equal to this arc here. So TK arc is equal to TN. So that means that I have 5x minus 10 degrees is equal to 2x plus 80. So 5x minus 2x equals 80 plus 10. 3x is equal to 90. Divide by 3, so x is 30. So if x is 30, that means that I have, now, I didn't get into using, it says the measure of angle T, this angle here, is a half y plus 28, and it says find what y is. So I have to find what the measure of this angle is right here in order to find what y is. So I got x, so let's put down, let's get the, I can work out, so what I'm going to do, I'm going to get the measure of this arc here, and then this is an inscribed angle cutting off this arc. So I'm going to get the measure of this arc, take a half of it and put it here. And then this angle right here would be the same size as this one because two sides are equal, these two angles are equal. And then when I subtract these two angles from 180, I'll get the size of angle T, and that'll allow me to find a y. So here we go. So I have the arc TN is equal to 5x minus 10. So that means that x, so the arc TN is 5 times 30 minus 10. So that's 150 minus 10, which is 140. 140 degrees. So that means this arc is 140. So that means this angle, that means also this is 140. This arc right here is 140. So if this arc is 140 and this arc is 140 because they're equal, so if you put 30 in here, 2 times 30 is 60. 60 plus 80 is 140. So they're equal. So this angle in here is the half of this arc. So this angle is 70. This angle is 140. So this angle is half the intercepted arc because this is an inscribed angle intercepting this arc. So this is 70. This is an inscribed angle intercepting this arc. So this is 70. 70 and 70 is 140. So that makes that angle at T 40 because it adds up to 180. So that means that a half y plus 28 degrees is equal to 40 degrees. So I can go a half y equals 40 minus 28. A half y equals, and that's 12. If I subtract right, that's a 12. 40 subtract 28 is 12. Multiply by 2, and you multiply both sides by 2 now because I got a fraction. So that means y equals 24. Multiply by 2. 12 times 2 is 24. So y is 24. So when I put 24 in here, half of 24 is 12. 12 plus 28 makes 40. And that means that if you think about it, this is a 40, and these are 70s, that adds up 180. But if this is a 40, this arc KN is also double that, because this is an inscribed angle, half the arc. So 80, 140, 140 should add up to 360 to make sure. Okay, let's continue. Sorry about that little error here. I forgot to change that. This is the arc TN. And one more. Number 4. An equilateral triangle is inscribed in a circle. Find y if y squared minus 58y is the measure of the minor arc. So what we have is that it's an equilateral triangle inscribed in a circle. So what we have is let's draw a circle. So when they say an equilateral triangle, a triangle is inscribed in a circle, they mean that all the vertices of the triangle are on the circle. So this is an equilateral triangle whose vertices are points on the circle. So because the vertices of the triangle are on the circle, then we say this triangle is inscribed in the triangle. So because it's an equilateral triangle, that means all the sides are equal. And if you've got an equilateral triangle with all sides equal, we all know that all the angles are 60s. An equilateral triangle got all 60-degree angles because they're all equal. And at the same time, what happens? This is an inscribed angle intercepting this arc. So this arc is 120. This angle right here is inscribed intercepting this arc. So this arc is 120. And this angle here is inscribed intercepting this arc. So this arc is 120. Because the arcs are double the inscribed angles, or the inscribed angle is half the arcs. So the circumference going around the circle is 360 degrees. So that means that one of the arcs, so we got y squared minus 58y is equal to the measure of the minor arc. Notice these three arcs are minors, so that is equal to the measure of one of the minor arcs, since they're all the same. This is a quadratic, so you got y squared minus 58y minus 120 equals 0. A quadratic, hopefully, is factorable. Notice we have a product of a negative 120, and we have a sum of a negative 58. So what are the factors? If this is factorable, that's going to, well, 120 product is 1 times 120. 58, well, let's take somebody 10 times 12, 20 times 6, we have a 2 times 60 gives me 120. You keep looking for it. What we're doing, we have a product of a negative and a sum is negative. So that means the factors have to differ by 58. So instead of going on, I could have went with more factors. I could have went with a 3 times 40. But I need a pair of factors that differ by 58, and 2 and 60 doesn't. So y and y, 60 and a 2. Product is negative, sum is negative, so I have negative 60 plus 2. Because we have a 1 here, then it's easy to see these factors. That will have a product of negative 50 and a sum, product of a negative 120 and a sum of negative 58. So y minus 60 equals 0, or y plus 2 equals 0. So y is equal to 60 as degrees, and y is equal to, yes, 60 degrees, 2 degrees. Because you're going to be a degree. Now, we got to, be careful. I said y is 60. So you bring the negative over, make it positive. Bring the positive over, make it negative. Now, we would say y is negative. We would take it and say, no, it don't fit. 60 would be okay. But we got to check. Y squared minus 58y. So if we take 60 and square it minus 58 times y, so 60 squared is 3,600. 58 times 60 is 3,480. Subtract and you get 120. So 60 is okay. Now what about if I sub in y is negative 2? So negative 2 for y. 58 times negative 2. PEMDAS, again, we do the square first. So negative 2 squared is 4. Negative times the negative is positive. So 58 times 2 is 116. adds up to 120. So that's okay. That one's okay. So there's two values of y that will fit what we're saying here. So when y is 60, this is true, we get 120, 120, 120. When y is negative 2, we get 120, 120, 120. Again, just a sort of a different problem. But notice that here we got an inscribed triangle, but also we have what? All of these chords are equal. So if this chord is equal to this chord, then these two arcs are equal. But since all three chords are equal, that means all three arcs are equal. So 360 divided by 3 gives you each arc is 180. Or all angles in the triangle are equal, 60 each, because we got an equilateral triangle. 180 divided by 3 is 60. And it makes sense that the arc is double the inscribed angle, or the inscribed angle is half the arc. Here's the arc, here's the inscribed angle. Either way. So that brings us to the end of another video. And again, if you like my video, click on the like button, click on the subscribe button. If you're not a subscriber, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.